Hello, STT 315. This is Recitation 12. So we're picking up from where we left off from Recitation 11. So we're on question 10. A newspaper agency wants to estimate the proportion in a population who will buy their new news magazine using a 95% confidence interval. Information from sale of similar magazines suggests a prior guess of 0.2 for the proportion. How large a random sample would be necessary for the interval to have a margin of error of 0.015 or less? So we're going to have to find n, which is greater than or equal to k squared times p times 1 minus p divided by m squared, which is our margin of error. So first we need to find out what our k is. So we're going to use the fact that we have a 95% confidence interval. So to calculate k, we're going to do inverse norm of 1 plus our level of confidence, 0.95, divided by 2, and that gives us 1.96. So that's our k for problem 10. So we have 1.96 squared times, and then our p is 0.2 because we were told that prior guess for the proportion is 0.2. And then 1 minus p is 1 minus 0.2, which is 0.8, and then divided by m squared. And here our margin of error is 0.015. So we're going to square that. So when you plug this into your calculator, you'll get that n is greater than or equal to 2,732. Now question 11. A real estate agent needs to estimate the average value of a residential property of a given size in a certain area. The real estate agent believes that the standard deviation of the property is 4,900 and that property values are approximately normally distributed. A random sample of size 16 units gives a sample mean of 90,000. Give a 95% confidence interval for the average value of all properties of this kind. So here we're going to have our confidence interval, and we're going to first need our margin of error, and then we'll do our mean plus and minus our margin of error. So m equals k times sigma, our standard deviation, divided by the square root of our sample size n. So here we are we would need to find a 95% confidence interval. So 95% is our level of confidence. So our k is going to be the same as question 10, because when you do inverse norm times 1 plus 0.95 divided by 2, it's 1.96. So for problem 11, our k is also 1.96. And then our sigma, our standard deviation, it is 4,900. That's given to us. And then we're going to divide that by the square root of our sample size, which is given to us as 16 units. So when you solve that, you get 2,401. That's our margin of error. So we need to take our sample mean, which is 90,000, and then plus and minus our margin of error. And when we do that, our lower bound of our confidence interval is 87,599, and our upper bound is 92,401. Number 12, Beechcraft Incorporated wants to estimate the average time it takes the Beechjet Corporation jet to climb from sea level to 45,000 feet. From previous experience, company's engineers believe that the standard deviation of climbing time is 5 minutes. The model is tested in 100 random trials, and it is found that the sample mean is 20.5 minutes. Give a 99% confidence interval for the average climbing time from sea level to 45,000 feet. So here, now our k is going to be 99. Now our k is going to be different than before, because previously we were doing 95% confidence intervals, but now we're doing a 99%. So we're going to do inverse norm of 1 plus 0.99 divided by 2. So our k is 2.576. So when we're solving our margin of error, so we just found our K. Now our sigma is 5. We're given that the standard deviation of climbing time is 5, and then divided by the square root of our sample size. And the model is tested in 100 random trials. So 100 is our sample size. So when you compute this, m equals 1.288. And so our confidence interval is going to be our mean plus and minus the sample or the margin of error. So our sample mean is 20.5. So 20.5 plus and minus 1.288. So our lower bound is 19.212 and our upper bound is 21.788. Number 13, a tire manufacturer wants to estimate the average number of miles that may be driven on a tire of a certain type before the tire wears out. A random sample of 25 tires is chosen. The tires are driven on until they wear out, and the number of miles driven on each tire is recorded. The data in thousands of miles are as follows. So here we have a list of number. This is the data that they're referring to. So here we have a list of 25 different numbers. So our sample size is 25, and that's also given, but you can also count them individually. And then you can calculate your X bar. So our sample mean is 1 divided by the sample size, which is 25, and then times us adding all of these numbers together. So when you do that, when you add them all together and divide by the total, you get 28.44 as the sample mean. Then the sample standard deviation is going to be the square root of the sum of the xi's minus our sample mean squared divided by n minus 1. So when you do that, you get the sample standard deviation of 4.9923. So I just did this because we'll be using this in the next questions. So far, we haven't been given a task. Now here is our first task. So give a 95% confidence interval for the average number of miles that may be driven on a tire of this kind. So our confidence interval is going to be our X bar plus and minus our margin of error. So we found that our X bar previously is right here is 28.44, but now we gotta backtrack and find our M. So here our M is going to be K times S divided by our square root of N. And here we also note that we're in the, okay, sorry, I'm kind of getting ahead of myself. So in order to calculate our M, we're going to need to calculate our K. So here, instead of doing inverse norm, we're going to do inverse T because we're in a small sample situation since our sample size is less than 30. It's 25. So we're going to do inverse T of 1 plus 0.95 because we want a 95% confidence interval divided by 2. And then our degrees of freedom is 24 because to find degrees of freedom, you take the sample size and then minus 1. So our sample size is 25, but then you subtract 1 and that's 24. So that's our degrees of freedom. So when you input this in your calculator, you get K equal to 2.0639. So now we're ready to finally compute our M. So here we have our K, and then our S is our sample standard deviation. So here that's 4.9923. That's what we calculated up here, and then divide by the square root of the sample size, which is 25. And that gives us 2.0607. So that's our M. So now we're ready to finally do our sample mean plus and minus M. And so we have 28.44 plus and minus 2.0607. And our lower bound of our 95% confidence interval is 26.3793. And our upper bound is 30.5007. Oops, I skipped a page. Okay. Oops, I don't know why this is happening. Hold on. Okay, I'm trying to scroll too much at a time. All right, now we're on question 14. An airline wants to estimate the proportion of business passengers on a new route from New York to San Francisco. A random sample of 324 passengers on this route is selected, and 144 are found to be business travelers. Give a 95% confidence interval for the proportion of business travelers on the airline's new route. So here we're going to have p hat. Well, we're going to need to find p hat, which is 144 divided by 324. So we take the number of business travelers divided by the total number of passengers. And that gives us 0.444 repeating. So now we're going to find our K. So our K is going to be inverse norm of 1 plus 0.95, because we want a 95% confidence interval, divided by 2. So our K equals 1.96. And so now we finally have the pieces to find M. So M equals K times the square root of P times 1 minus P divided by N. So our K is 1.96. We just found that out. And then our P is going to be 0.44 repeating. So our 1 minus P is going to be 0.5556. And then we're going to divide that by the sample size, which is 324. So our M equals 0.0541. And now we're ready to do our confidence interval calculation. So we're going to do our p hat plus and minus our margin of error. So our p hat is 0.444 plus and minus, and then our margin of error of 0.0541. So our lower bound is 0.3903 and our upper bound is 0.4985. Okay, number 15. Find the minimum required sample size for estimating the average return on investments of a certain kind to within 5% per year with 95% confidence. The standard deviation of returns is believed to be 1.5% per year. So our N is going to be greater than or equal to K squared times sigma squared divided by our M squared. So here we have a 95% confidence level. So we have our K equal to 1.96, and this is how you can, it's the same equation. And then we have our standard deviation of 1.5, that's given to us here. And our M is 0.05, which is given here. So now we're ready to just plug and chug. So our K squared, 1.96 squared times sigma squared, which is 1.5 squared, divided by our M squared, which is 0.05 squared. So when you solve that, you get that N is greater than or equal to 3,692. All right, now we're on to our homework questions. So the time in minutes passengers must wait for a commuter plane in a main train station is uniformly distributed on the interval 3 to 15. So what is the probability that a passenger waits less than 13.2 minutes? So it's basically asking us to solve what is the probability that X is less than 13.2 and our X is uniformly distributed. So to solve that, you do B minus A divided by D minus C. So here, sorry, this should be C and then D. I kind of mislabeled. So you would do 15 minus 3 in the denominator, which is our upper bound of that interval, and then our lower bound of that interval. And then our numerator is going to be 13.2 minus 3. So why is that? So if I were to draw the uniform distribution that we have, so X follows uniform 3, 15. So here is 3 and here is 15, which is C and D. And then here we have 13.2 is somewhere over here, and we want to find this area under the curve. So we're going to do, so the denominator is always going to be that D minus C. So the upper bound of the uniform distribution, and then minus the lower bound. But then our numerator is going to be like that area we're interested in. So it's going to be 3.2 minus, and then our lower bound would be 3 here. So then you get 10.2 divided by 12, which equals 0.85. So that's the area under the curve there. And then what is the value of expectation of x? So for a uniform distribution, it's 1/2 times c plus d, 3 being c, 15 being d. So when you solve that, you get the expectation of x equal to 9. Assume that x is uniformly distributed random variable with mean 7 and variance 3. Find the probability that x is at most 7.6. So here we have our expectation of x is, well, first we have to find what our c and d is, and then we can solve what the probability that x is less than or equal to 7.6. So here we're given that the mean is 7, so that's expectation of x is 7, and the variance of x is 3. So that means our standard deviation is the square root of 3. So since we're in the uniform random variable setting, our expectation of x is 1/2 times c plus d. And our standard deviation of x for a uniform random variable is d minus c divided by the square root of 12. So here we have two different equations. So we'll solve the system of equations to get our d and our c. So if you take this equation and the 7 equals c plus d divided by 2 and solve for c, you would get c equals negative d plus 14, because you would multiply by 2 on both sides and then subtract over the d to isolate c. And then to solve for c for this second equation, you're going to take, do the same type of thing. So just solve for c algebraically. So we're going to multiply by the square root of 12 on both sides, so that denominator will cancel out, and then subtract d and then divide by -1 on both sides. So in the end, you'll get c equal to -6 plus d. So here, these both equal to c. So to solve a system of equations, we can just equate these two expressions together. So we get 14 minus d equal to -6 plus d. So when you solve that, if we add d on both sides, we get 2d here. And then if we add 6 on to the left, then we get 20 equals 2d. So then you divide by 2, and then our d equals 10. So then to see what our c is, we can just pick one of these equations and then plug in what we know our d to be. So c equals -6 plus our d, which is 10. So our c equals 4. So here we have a uniform distribution where c is 4 and d is 10. But remember, the question is find the probability that x is at most 7.6. So that equals the probability that x is less than or equal to 7.6. So our denominator is going to be our our d value, so that's 10, minus our c, which is 4. And then our numerator is going to be that range of what we're interested in. So our upper bound there is going to be 7.6, and then our lower bound is at 4. So when you solve that, you get 0.6, which is the correct answer. The life of a new miniature battery is uniformly distributed between 3 and 9 hours of continuous use. Law enforcement requires that it lasts at least 7.8 hours. What is the probability that X meets the law enforcement standard? Okay, so here we still are in a uniform distribution, and we have uniformly distributed between 3 and 9 hours. So our C is 3 and our D is 9. And it's saying, what is the probability that X is at least 7.8? So that's X is greater than or equal to 7.8. So this is the same type of method we just did. So our denominator is going to be our D minus C, so 9 minus 3. And then our numerator is going to be the area that we're interested in. So our upper bound is 9 and our lower bound is 7.8 because we want X is greater than or equal to 7.8. So when you solve that, you get 0.2 as your answer. The number of votes cast in favor of a controversial position is believed to be approximately normally distributed with mean 7,000 and standard deviation 500. The proposition needs at least 7,835 votes in order to pass. What is the probability that the proposition will pass? Assume numbers are on a continuous scale. So here we have, so X is approximately normally distributed, and we're given that the mean is 7,000 and standard deviation is 500. And we want to know, so the proposition needs at least this many voters. So what is the proposition it will pass? So in other words, it's asking, what is the probability that X is at least 7,835? So that means, in other words, X has to be greater than or equal to 7,835. So here, if I draw my normal curve, and our mean is, so it's centered around 7,000, and so 7,835 is somewhere to the right of it, and I want the probability that X is greater than or equal to that number. So we're shading the right-hand side of 7,835, and now we're just doing our normal CDF. And so then we have our lower bound of 7,835. Our upper bound is going to be infinity. And then our mean is 7,000 and our standard deviation is 500. So when you input that, you should get 0.04746. So when you round it up, you get the correct answer there. So an advertising research study indicates that 30% of the viewers exposed to an advertisement try the product during the following 4 months. If 100 people are exposed to the ad, find an approximate value of the probability that at least 25 of them will try the product in the following 4 months. Choose the closest answer. Okay, so our P is going to be 0.3 because that's the percentage of the viewers exposed to an advertisement. And so we're going to use a binomial. So we have the probability that P is greater than or equal, or P hat is greater than or equal to 25. So that's going to be equivalent to 1 minus P, the probability that X is less than or equal to 24. So here we have 1 minus, and then this can be computed to do the computed by doing binomial CDF NPK. So N is our sample size of 100. P is 0.3, and then our K is 24 here. And then you put that in your calculator and you get 0.8864, and the professor said that you're just supposed to pick the closest option. So the closest option to that is 0.8641. A bottling plant wants to sell bottles with 1 liter of water. The amount of water filled by the machine while remaining close to 1 liter varies from bottle to bottle. The amounts filled in bottles can be modeled as a normal with standard deviation sigma and mean 1 liter. The manufacturer wants to set sigma such that nearly 68.26% has filled between 0.8 and 1.2 liters. To achieve this, sigma should be set close to, okay, so we need to find what sigma should be close to. So X, it follows a normal distribution with our mean of 1, and our standard deviation sigma. So we currently don't know what our sigma is, but we're trying to find what it should be close to. So, and we're given that 68.26% has fill between 0.8 and 1.2 liters. So if I were to just draw what we know, we have our normal distribution centered around 1, which is our mean, and then 0.8 to the left, 1.2 to the right of that, and then that area under the curve is 0.6826. So here, that probability, the probability that X lies in this range here is normal CDF. 0.8 is our lower bound, 1.2 is our upper bound, 1 is our mean, and then if you do trial and error, and when you input 0.2, you get that your area under the curve is 0.6827, and we were given that it's 0.6826, so that's pretty close to the area we were given under the curve. So sigma equals 0.2 is the closest, which is the correct answer there. Weekly earnings on a certain import venture are approximately normally distributed with a known mean of 105 and unknown standard deviation. If the probability that earnings is over 72.961 is 0.9, find the standard deviation. So here we're given that X is a normal distribution, our mean is 105, and we don't know what the standard deviation is. So we're just going to say it's sigma. And then we're given that the probability that X is greater than, which is the earnings, is over 72.961. So that probability is 0.9. So that's what we're given. So in other words, you can standardize it by subtracting by the mean and dividing by the standard deviation. So 0.9 also equals the probability that Z, being our standard normal variable, is greater than 72.961, and then minus our mean 105 divided by our sigma. So in a standard normal situation, we remember the mean is 0 and the standard deviation is 1. So if I were to draw what we know, we have in the standard normal, once it's standardized, so our mean curve is centered around 0. We have that the probability, or the area under the curve, is 0.9. And so we want to find what is this value here. So our inverse norm, okay, so here we have inverse norm, our area is 0.9, and then our mean is 0, standard deviation is 1. So we get that value here, the cutoff value, to be 1.28155. So we know that this here should equal that cutoff value, 1.28155. So we have, now we have this equation here, and we can now just solve for sigma, knowing that sigma is greater than, is always positive. So when you solve for sigma, you get that sigma equals 25, which is the answer that we were looking for. The scores of a test designed to measure the reading ability of children has mean 32 and standard deviation 5. It is desired to make a linear transformation x new equals a plus x plus bx, with b positive, so that x new has mean 39.6 and standard deviation of 6. So what is b? So here, I'm going to just zoom out so we can see everything that's going on. So we want to know, what is our b, what is our a, and then we have another question too after that. So here we get that our x, so our x new equals a plus bx. So our expectation of x new is going to equal a plus b times the expectation of x, because a is just a constant. So the expectation of a constant is just a constant. And then an expectation of b times x is going to be just b times the expectation of x. So here we can plug in the numbers that we're given. So we're given that the expectation of x new has mean of 39.6. So that will go here. And then we have equals a plus b, which we don't know what b is, or a, and then times the expectation of the original x, which has a mean of 32. So we have one equation there. And then we also can have another equation of a and b, or really of b, and then basically solve that system of equations by using the variance. So the variance of x new is going to be the variance of a plus bx, because that's what our x new is. But when we solve this, we know that our new variance here is going to be 6 squared, because we're given the standard deviation, so be careful. But the variance is going to be 6 squared, because the variance is a standard deviation squared. And then that equals, so when you take the variance of this expression here, the variance of a constant is 0. There's no variance in a constant, it's just a constant. And then the variance of b times x, well, when you take out the constant, that's multiplied by a random variable, you square it, so you get b squared times the variance of x. So when we plug in the numbers we know, so 6 squared is 36, b squared, we don't know what b is yet, and then our variance of x, like our original variance, is going to be 5 squared, because we're given that the standard deviation is 5. So you're going to do 5 squared here. So now let's first solve for b, and we'll use this equation because we just can isolate b. There's no a in this equation. So we get b squared equals 36 divided by 25, and then you can take the square root to isolate b, which is 1.2. So I didn't write down all my steps, but essentially you would just take, you would divide both sides by 25, which is 5 squared. So that's why you get 36 divided by 25 here. So our b is 1.2. So that answers that first question. Now we need to find our a. Well, we have this equation here, but now we know our b, so we can plug in our b, which is 1.2. So when you plug that in, we get this equation of 39.6 equals a plus 1.2 times 32. So when you subtract this on both sides, you get 1.2 equal to a. So a is also 1.2. And now we have one last part. So if a student scores 11, what would be the new transformed score under the new scale? So it's saying, let's say if a student scores 11, so x is the original score, and now we want to find what is the new score. Well, x new equals a plus bx. So our x here is 11, and then we just found that a is 1.2 and b is 1.2. So our x new equals 1.2 plus 1.2 times 11, and that gives us 14.4. A large freight elevator can transport a maximum of 10,080 pounds. Suppose that a load of cargo containing 36 boxes must be transported via the elevator. It is known that the weight of a box this type is a normal random variable with mean 270 pounds and standard deviation of 20 pounds. What is the probability that all the boxes can be sent simultaneously through the elevator? So here we have that x is a normal random variable, and then we have our mean of 270, our standard deviation of 20. And so here we're going to use our central limit theorem Our N is 36. So I'm just writing down what we know. So now we're going to do the probability that the sum of our xi's is less than or equal to 10,080. So by the central limit theorem, we get that when we subtract by n mu and divide that by the square root of n divided by sigma on both sides, we get this expression on the left-hand side is less than or equal to, and then we have 10,080 minus, so our 36 is n, our mu is 270 here, divided by the square root of n, which is 36 times 20. So which once you standardize it, that's the same thing as saying the probability that z is less than or equal to 3. So here, if I were to show what we have with the normal curve, we have it centered around 0, or with the standard normal curve, we have it centered around 0, which is our standard mean of a standard normal variable. And then we want the probability that z is less than or equal to 3. So we're going to do our normal CDF, and our lower bound is negative infinity. And then our upper bound, we stop at 3. And then for standard normal, our mean is 0, and our standard deviation is 1. So when you compute that, you get 0.999. So that is the answer here. That's correct. Okay. And then this is the last question, I believe. Yep. Okay, so each year a company must send one official to a meeting in China and one to a meeting in France. Airline ticket prices vary from time to time. The price of tickets to China has a mean of $3,000 and a standard deviation of $260. The mean and standard deviation for the tickets to France are $1,000 and $70 respectively. The total amount that the company sends is thus x plus y. The mean of the total amount that the company has to spend to these officials. So now we want to find what does that mean? So we want to find the expectation of x plus y. So that is equivalent to the expectation of x plus the expectation of y, which equals, so we were given this. So for China, we have 3,000, and then for France, we have 1,000 as the mean. So when you add those together, it's 4,000. So that is the mean of the total amount the company has to spend. Now we want to find the standard deviation of the total amount. So that's going to be the square root of the variance of x plus y. So the variance of x plus y equals the variance of x plus the variance of y plus 2 times, excuse me, the covariance of x and y. So here, because of independence, our covariance is 0. So we just have the square root of variance of x plus the variance of y. So our variance of x is going to be 260 squared, because in the problem we're given the standard deviation. So don't forget to square it when you're using it as the variance. So we get 260 squared. And then the variance of y is going to be 70 squared. So you take the square root of those two numbers added together, and you get 269.26. Now assume that the prices are normally distributed with means and standard deviations given above. If the company has a budget of $4,404, what is the probability that both officials can go to their meetings? So in other words, it's saying, what is the probability that the total amount the company spends is less than or equal to that budget of 4,404? So we're just going to do a normal CDF of this x plus y random variable. So our lower bound is going to be negative infinity, And then our upper bound is going to be that 4,404. And then we have our mean of x plus y, we just found is 4,000. And our standard deviation of our x plus y variable we just found is 269.26. So this, once you put it into your calculator, you should get 0.9332 as that probability. And this concludes recitation, and I hope this was helpful. Bye.